And now let's look at example 2. This is with trig involved. When trig is involved, we're going to use our formula chart. So I got the formula chart open, and I'm going to scroll down until I find this formula here. It says that sine squared theta plus cosine squared theta equals 1. And that's the formula we're going to use to solve this. Now I'm going to change the order just because we usually write x first. So cosine is x. So cosine squared plus sine squared theta equals 1. To solve this problem, you're going to substitute in here. Now we got to make these identical. So this x equation has cosine. I need to make this cosine squared. So the first thing I'm going to do is square both sides. When I square both sides here, I'm going to have x squared equals 9 cosine squared t. Now the next step to get cosine squared by itself is I'll divide both sides by 9. So now that I know that x squared over 9 equals cosine squared t. Now that's what cosine squared t is x squared over 9. Now I move over here to the y. Now this one I can do the same thing. Now some people might have thought, well, if I wanted this, I would have divided first. Well, that's fine. If we would have divided first, we can still get the same answer this way. So if we divide, we get y over 5 equals sine t, and we still need to square it. So now at this stage, I would say, okay, let's square this, and let's square this. So give me y squared, fractions is top times top over bottom times bottom, and 5 squared is 25 equals sine squared t. Now that I have that, I would substitute this over here, and I would have this equation. This part, the plus would not change, and the equals 1 would not change. That should be my equation. Now we've eliminated the parameter. We can check our work. This right here is an ellipse. And again, if you didn't know that, you could go here to your formula chart and scroll down, and you look at an ellipse, and you'll see it matches this form. All right, so we're back over here. And to graph these, I'm going to type in the original equation. So I go here to my graph, and this is a parametric. So window, graph entry, parametric, and it was 3 cosine. Oops, what was I pressing? Let me try this again. 3, go to trig, click cosine, and we're just going to put a t there. Now the other equation was 5 sine of t, and it doesn't give us a t. So normally I go from -10 to +10, but when it's theta, this represents 0 to 2 pi. That 6.28 is 2 pi, and that's all I need. So I'm just going to graph here, and let me double check. Yeah, there's no t values listed, so I'll just leave it like that. And so this would be my graph here. So I'll take this over. Well, actually, now let's compare it with the ellipse formula that we got. So you go menu, graph entry, go to equation, choose an ellipse. And this, we had nothing up in the parentheses with x and y. They were just by themselves. But down the bottom, we had 9 underneath the x squared and 25 there. Now remember, they changed the form here, and it has the squareds. So we're just going to, I just type in square root of 25, because the square root and the square will cancel. And over here, you can do the square root of 9. Again, I know you probably know that the value should be 3. I just do that in case we get a random one, like say square root of 20 that we don't know what to do with. We can just leave it like that. And when I press enter, notice that we get the exact same equation. So we did, in fact, do this one correctly. Now let's take a look at example 2b. Now we have this form. So my first step is, again, I want to get it in that, like that problem, or which was cosine squared, not the problem, sorry, the Pythagorean identity, plus sine squared t equals 1. That's what we're going to look to substitute to. So the first thing I need to do here is add 2 to both sides. So I now have x plus 2 equals 3 sine t. I need to get sine by itself, so now I'll divide by 3. Like this, or you could square it. Either way is fine. Let's say you wanted to square it. You could do this as well. So when I square it, I would then have, I'm just going to leave this as x plus 2 quantity squared, rather than working out that perfect square, equals 9 sine t. And finally, the last step is you would then divide this by 9. Oops, I forgot the squared there. That needs to be a squared. And so you now divide by 9. And so we get that x plus 2 squared over 9 equals sine squared t. So that's going to replace over here. X plus 2 squared over 9. Now someone might be wondering, I thought sine was supposed to go with x. It is, and it'll affect how the graph, the orientation of the graph. We'll get to that in a second. So let's go over here and do the same thing. I want to add 5 to both sides. That goes away, and so I have y plus 5 equals 2 cosine of t. Now we can square both sides. So we'll square both. So I'm just going to leave this as y plus 5 quantity squared equals, this becomes 4 cosine squared t. Last step, now divide by 4, which that gets canceled away. And so we have y plus 5 squared over 4 equals cosine squared t. So I substitute. So here I have y plus 5 quantity squared over 4. And this would be a plus, and that would equal 1, because when we substitute, that stuff would remain. So we now got our answer. So now let's check out the graph and what happens. So I'm going to come over here to my graph. I'm going to add a new page. So Control Dot gets me a new page. I want to add it. This is a graph. And so the first equation they gave me is parametric. So graph entry, choose parametric. X was 3 sine t minus 2. So 3 sine t minus 2. The y equation was 2 cosine t minus 5. 2 cosine t minus 5. The t values were from 0 to pi over 2. Pi is down here in the bottom corner. Pi over 2. Press enter. And here's my graph. It looks very small down here. It's kind of just strange. It's a little piece. So now let's check this and see if it matches. And that's an elliptical form. It's a positive here. So I come back over my graph. I'm going to go menu, graph entry, equation, choose an ellipse. And here, now notice they were going to put the x first. So we come over here, and it's x plus 2. But this does not have a plus. You're going to do a minus 2 there. Because a negative of a negative, or a minus of a negative, makes it positive, over. And instead of 9, they have a squared there. You could put 3, or we can just do square root 9, like this. Then we come over to the y equation, and it was y plus 5 over 4. So it's y, the minus is already there, and so I want to do minus 5. That'll make that turn positive, over, and I believe it was 4 in the denominator. So instead of 4, we're going to put square root 4. That way they can cancel out when I press enter. Notice it's the same ellipse, just this has more graph to it. And the reason why is this part here has this part of the graph like that. It's limited in its t values. That's why it looks like that. So this should be our picture here. And now I'm going to show you what that t value did and what happens when you flip x's, the sine and cosine. What happens if I go to menu, trace, graph trace, it's going to first ask me, or I thought it was going to ask me what equation, but it just went straight to this parametric, which is good. What happens is you'll notice at time equals 0, we're going to be at the top portion of this graph. What just happened? Sorry. Let me just hit the left arrows like this. When time is 0, this graph is going to start at the top. But when you normally graph with sine and cosine, we should be starting on the x-axis, not on the y-axis. Now I know this is the y-axis. This is with a shift. So this top point is representing the y-axis. This point over here is representing the x-axis. What happens since we're going x with sine and y with cosine is this graph starts at the top, and it's going to move the opposite direction. It's going to move right, or not right, but it's going to move clockwise this direction as time moves on. And you would see this would be the value, though it doesn't say it, this would be the value right here of pi over 2. So that's what's happened there. Now let's go backwards to the previous problem. Now the previous problem that we just had, we had cos with x and sine with y, which is the way it's supposed to be. Well, if I went to my calculator and if I wanted to trace this, when I went to graph trace, what would happen is time 0 would not be on the y-axis or at the highest point. It would actually be time equals 0 would be on the x-axis right there. And you'll see that as we move on, this would be, it moves counterclockwise. This would be pi over 2, so it should be about 1.57, which it doesn't show it. This would be the value pi, so it would be 3.14 if we hit exactly on the x-axis here. This would be 3 pi over 2, and if you went all the way around, you'd have 2 pi, which is 6.28 right there. And so you can see how these work. Now let's check out example 2c. What we're going to do first is we're going to get it in that formula. Remember, again, it's cosine squared theta plus sine squared theta equals 1. That's from the formula chart. So this, to get its cosine squared theta, I just add 7. So that means that x plus 7 equals cosine squared theta. Now I come over here, and this one, to get in the right form, I'm going to first subtract 4 over on both sides. So that goes away. That one went away over there. So to have y minus 4 equals 3 sine theta. Next, I need to divide this by 3. Or I could square it. Let's just go ahead and square it. So if we want to square it, I get y minus 4 quantity squared. I'm not going to work that out because that's a good form for us. Equals 9 sine squared theta. Finally, you would divide by 9. And now we find out what sine squared equals. It's this. So when, now that we have that y minus 4 squared over 9 equals sine squared, we can substitute it into the problem. So when I substitute that, I'm just going to move it over here. I'm going to have, for cosine squared, x plus 7, and then sine squared plus y minus 4 quantity squared all over 9. To finally get this right, equals 1, sorry. Now, to finally get this in the right form, I got to determine what shape this is. Since I only have 1 squared, it's a parabola. And so when I go to the formula chart, as you see on a parabola, you either have your x squared on the left or the right y squared on the left. And that's by itself. So I need to move this stuff over. So the first thing I'm going to do is I'm going to subtract an x. I'm going to subtract a 7 from both sides. Subtract an x, subtract a 7. These go away, these go away. So I have y minus 4 quantity squared all over 9 equals negative x minus 6. And you combine like terms right there. Last step. How do I get rid of the division by 9? You multiply by 9. So I'm going to multiply this side also by 9. Now I'm going to come back over here. To point out this formula, you keep this other parenthesis with either the variable going first and by itself. So I'm not actually even going to distribute that. If you wanted to, it's okay. But you're going to undistribute it right back. What do I mean? Let me show you. You'd have y minus 4 quantity squared, then you would have negative 9 minus 54, negative 9x, I'm sorry. And the last step would then be, you got to factor this out. So you get x by itself, which this value would change. And so finally we get our answer. It's y minus 4 quantity squared equals negative 9x. Negative 54 divided by negative 9 is positive 6. There's my answer. Now if we wanted to graph these, just to check, again we go back up here and I'll type these in. So come up here, I need to add a new page, graph, and my first equation was cosine squared theta. So I would type in cosine, parentheses, and we're not using theta, we're going to use t, and you have to put the squared on the outside, like that. Cosine squared theta minus 7, and just realize I'm in function here. I need to go menu, graph entry, parametric. Let's try this one more time. Cosine t, put the squared on the outside, minus 7, and underneath we have 3 sine plus 4. 3 sine theta, so sine t, plus 4. And I don't believe they gave us a t value. They did not. So when they don't give us, a lot of times you can go negative 10 to 10, but for this, I'm just going to leave it as it is. Press enter. Here's my graph. It looks like a horizontal parabola. So to check it, we're going to go graph entry, equation, parabola, and we are in vertex form. That's the form we have for our answer down here. It's a vertex, or that's not even vertex form, I'm sorry. Calculator doesn't, we would actually go closer to what we had before. Let me see up here for the calculator. This is the way, this is in our best form, but the best way for the calculator would be something near here. Let me just kind of go backwards. The calculator would want, I'm going to just choose here vertex form with x equals, and I'll convert it real quick for you. You'd want the x by itself. So again, we had it distributed a moment ago. If we distribute this again, I'll put the negative 9x minus 54 equals y minus 4 squared, like this. So I've just turned it around. Now I would add 54 over, like this. This goes away, and so now I have negative 9x equals y minus 4 squared plus 54. Last step, I would divide by negative 9, which means all this gets divided by negative 9. When you divide two things by negative 9, like you can divide the fraction and do it negative 9 here and negative 9 there. That'll be easier, which means I can type this in as x equals, this is like having negative 1/9 of y minus 4 quantity squared minus 6. Let's type it in like that. Back over here, it was negative 1/9, so negative 1/9 y with 4. I remember it was 4. Was it minus 4? So I just leave it. Already has the minus. And then over here it was minus 6. Negative 6 there. Press enter. And you'll see the graph matches perfectly. So we have, in fact, found the right answer. Those match. Finally, I have one more. Again, we want to get in that same formula. So here I need to add 2. And so I'd have x plus 2 equals sine squared t. And then I come over here and I need to get that cosine to become squared. So I'm going to first add 1 to both sides. So I have y minus 1 equals 4 cosine t. And at this stage, I'll square both sides. And so now I have y minus 1 quantity squared equals 16 cosine squared t. Last step, divide by 16. Now I have cosine by itself and sines by itself. So when I substitute into the formula, cosine squared t plus sine squared t equals 1. When I substitute for sine, I get x plus 2 here. When I substitute for cosine, I get y minus 1 squared over 16. That's a plus. That equals 1. So we now simplified. Now to get it into vertex form, or excuse me, standard form, I would subtract x, subtract 2. So I'm going to subtract x and subtract 2. Those go away. And so we have y minus 1 quantity squared over 16 equals negative x. I have 1 minus 2, which is negative 1. Finally, I multiply both sides by 16. And again, we're going to have to factor out what's common. So I can just factor out the negative right now. So I want to do that. That makes this positive. That makes this positive. So my final answer here, y minus 1 squared equals, I'm going to have negative 16, because negative 1 times 16. And then this became x plus 1 there. There's my answer. What would the parameter do? Since this is sine with x, cosine with y, we would not be graphing from the x-axis, but from the y-axis. And it would only graph the top half of the parabola. It would not go all the way around because it's not all the way to 2 pi. So we could graph these and check our answer. So let's start up here. So I'm going to hit a new dot. I need to see a new page real quick. And I want to go to graph, menu, graph entry, parametric, and the equation was sine squared theta, or sine t squared, with the squared on the outside, and minus 2. The other equation was 4 cosine plus 1, or cosine plus 1. And finally, the t value was from 0 to pi. So there's that part of the graph, and then we type in our other part of the equation. We could check our work. And so this for the calculator is not how you would type it in. You would actually, if we came back here, we almost had the equation, so I'll just take it from this black right here. You'd want the x to be by itself, which means that you'd still subtract the 2 over and get negative 1. But you'd also have to move this over. So I'd have negative, this is kind of like 1/16. So I'm moving this over first, times y minus 1 quantity squared. And then you would have the negative 1 on the outside. That's my equation there that I want to type in. So I'll go to here. I'm going to go menu, graph entry, equation, parabola, vertex form, x equals like this. You had negative 1/16. I don't know why I just did that. Let's try this again. 1 over 16 of y minus 1. I put the wrong minus. Let me change this to a negative 1. No, it needs to be minus 1. We already had the minus. There we go. And then finally on the outside, we had minus 1. So I put a negative 1 there. Hit enter. You'll see it's the exact same graph. So we did do it correctly.